Today we're going to have a really quick lesson about similar triangles and parallel lines. So we'll go over a couple theorems here, and the first one says if you have a line, so let's say DF, that's parallel to a side of a triangle and also intersects. So basically, if you have a picture that looks like this, if you have a line that's inside the triangle and is parallel to one of the sides, then what's going to do is it's going to create proportions, essentially. So for us, that means one of two things. You can either set up this following equation where basically you're taking one of the little pieces, we'll call it, and you're putting it over one of the big pieces, and that's going to equal the other little piece over the other big piece. So it's kind of easy to follow with that. You don't have to go that route. Instead, you could do little piece over little piece equals big piece over big piece. You just want to make sure that you stay consistent. So whatever you start with, whatever side you want to start with again. So you don't want to say like blue over yellow equals red over pink. You want to stay in the order, just kind of like we were doing from our similar triangles. So these are two sample problems you see. Again, these aren't very hard. So you could either look at it as x over 1 equals 12 over 3, or if you want, you can do big, like longer piece over longer piece equals short piece over short piece. Either way, the answer is 4. So you get 4 with either of them. This is the other type of problem you might see. So instead of giving you a label for the longer piece, I'll give you the whole thing. So really all you have to do is just take the whole thing minus this piece, and that's what you label this one. So it's kind of like what we did with those the H1S1 stuff. So now you can set up the following equations. You could do short over long equals short over long. You could do short over short equals long over long. Just got to make sure you start with the same side each time. Or if you really wanted, you could do short over total equals short over total. What you cannot do is long over total equals long over total. You don't want to do that. So any of these work, but no matter what, you should be able to work it out to get 5.25. So I'm not going to do that for you because we've done a lot of cross multiplying, but that's what you get. Next theorem, so you'll have three parallel lines. You can see 1, 2, 3. All right, you got transversals. Those are things that go through parallel lines. So this is the first one, and this is the second one. If you see a picture like this, it will also be broken into proportions. So that can mean a lot of different things. So what we'll do is we'll just write a couple of them. So the first one, you could have AB over BC. You could have this piece over this piece. Short over long still equals other short over other long. Oops, the FG. So this piece over this piece. You could have reversed. You could have long over short equals long over short. You could do short over short equals long over long. You could do short over whole thing. You could do AB over AC, and that equals DF over DG. So there's lots of different options that you could use to set these up. Just again, make sure that you stay consistent. What you do to one ratio, you'll make sure you set up the same way for the other one. So these are some samples. These are super duper easy. So it already even looks like a proportion for you. So we would do 5 over 7 equals x over 9. And cross multiply, you get 7x equals 45. Oh no, you get a fraction. That's okay. So my answer is 45/7. If I do 9 over 18, that's going to equal x over 24 minus x. You just make sure that you distribute when you go ahead and solve all that out. What I'm actually going to do is I'm going to reduce 9/18 to 1/2 because I think that's easier to work with. So I get 24 minus x equals 2x. Add the x over, that becomes 3. Okay, so we should end up getting 8 for that. I did work through that very quickly because it's not really that new to us. And then we got one more picture theorem that we need to know. So this is what the theorem says. You have a line of an angle, of a triangle. If you have a line that goes through an angle of a triangle, then it splits the opposite side into segments proportional to the other sides. Blah, blah, blah. What does all that mean? It means you'll have a picture like this. So you can do one of two things. Pick one of these pieces. So let's say you pick FD. You can either match that with FG or DE. Doesn't matter, but they have to have a letter in common. So maybe you'll do DE. So it's kind of like you're doing one side of the angle over the other side of the angle. And you're just going to match that to FG over GE. So a good way to think about it is whatever side you pick from this triangle, you want to make sure you pick the side from that triangle again. You want to start with the same triangle each time. You could have also done FD over FG since they're in the same triangle. So you're basically doing angle side over non-angle side. You got to do the same thing for the other one. So top or DE over bottom EG. So either of those work. So the pictures look a little weird. We definitely don't want to do the S1, S2 thing because that's only good for right triangles. These don't have any boxes in them, so we can't use any of those little theorems that I taught you. So a lot of kids will try to do 14 equals root 8 times 8 plus x. Right? You can't do that because there's no box. So that's not going to work. So instead you're just going to do proportions. So if you want to do the 14, you can either put that over 8 or you can put it over this side, which I don't know that side. So maybe I'll do 8. And then this side, I think they forgot to put a label, so we're just going to invent a label for that. We're going to say it's 20. So we're going to do 14 over 8 equals 20 over, and it would go with x. You make sure that if you do 14 that you do 20. You don't want to do 14 over x. That doesn't go together. It's either 14 over 8 or 14 over 20. One of the two. And then we just cross multiply, etc. So we get 160 equals 14x. We're going to divide by 14 on both sides. And yeah, we're going to get a fraction again, but it does reduce down to 80 over 7, which is workable. So we'll do 2 more just to make sure we got that in. I think this is the same one as before, but this time we're going to change it to 21. So, okay, we can do that. So let's say you want to do 14 over 8 this time. So 14 over 8 equals, I'd have to start with 21 and then put that over x. So then you're going to cross multiply. You're going to 21 times 8. I believe that's 168 equals 14x. Divide both of them by 14. And you're going to get 84 over 7. And I do think that goes in evenly. So it comes out to perfect 12. All right, again, one more time. Let's say you want to start with 9. Okay, you can either put 6 as the next number or 10 minus x. It does not matter. Let's say you want to do 10 minus x. That's going to equal 6 over, and I think they forgot yet another label for this. So let's do 4. Let's try that. So pretend that 4 was already there. We're going to cross multiply this really quick. 36 minus 60, that should be 24. And x is going to be a nice pretty 4 for us. So that's kind of the gist of it. Those are the 3 theorems. So it's basically just picture recognition. So you do a little practice problems. You should be fine with this chapter.